Hello, this is the question 2 of homework 5, and let's do it. So, given fxy equals this, and y is larger and equals than 1, and x is between 1 over y and y. So, the first question is draw the non-zero definition region of xy. So, from the definition region, we know that the x is larger than 1 over y and smaller than y. So we can draw them each of them. So first one is x equals 1 over y. The line is like this. And the right side is x equals y is this. And x between them. So x between this area. And y is larger than 1. So the point is 1 and x between 1 over y and y. So the region is this area. So this is the answer to the question 1. And let's look at question 2. Find A so that fxy is a valid joint density function. 1, it is a valid joint density function. It means 1, it is take the total area, which is 1 is from 1 to infinity, this is y, and from 1 over y to y, this is x. So we take it together, it should be 1. So we can calculation it by step by step. So the first step is this component is this is a y square ln x from 1 over y to y, and outside is dy. So this is to multiply ln y or a y square dy. And to calculation this, we now let ln y equals z. So ez equals y, and we turn the z into this and y into this, so we can get because y is from 1 to infinity. When y turns to z, the z is from 0 to infinity, so this is 0 into infinity, and this is a e to z, this is 2 multiplied z, and this is dez. So it can be turned to take the dez to dz multiply ez. So this is if 0 to infinity 2 multiply z and a e to z. This is ez dz. So this is a ez to z dz. And we turn this into a multiply form. So this is take the 2 over a outside of this, and we can get z e minus z dz. So and we can take this e minus z into this area. So this is a 2 over a, and this is minus z de minus z. And now we can calculation this by this is minus 2 over z, take the minus outside of this, and this is z e minus c from 0 to infinity minus from 0 to infinity e minus c dz. And when we calculation this, we know that this is 0, this is 0, and this side is e minus z from 0 to infinity. So this is 0, this is 1. So this is minus 1, and multiply this, we can get this as 2 over a. So 2 over a equals 1, and we get a equals 2. So this is answer of question 2. Now, so find and draw the marginal density functions fx and fy. We know that fx equals from minus infinity to infinity fxy dy. So we take the fxy into this. This is from minus infinity to infinity and 2xy squared dy. So to calculation this, we should split the graph into two parts. The first part is 1x. 1x is larger than 0 and smaller than 1. So this is the first area. And the second area is the red area, 1x from y equals x. So 1x larger than 0, smaller than 1. The y is larger than 1 over x and smaller than infinity. So this is from x minus 1 over x to infinity, and the answer is 1 over 2. And 1x larger than 1, the y is larger than x but smaller than infinity. So we calculate this, and this is x to infinity. So this is 2x squared. So we can get the picture of fx is 1x between 0 and 1. This is 1 over 2. And 1x is larger than 1, it is going to 1 over 2x squared. So the line is like this. And this is x, this is fx. So now we can calculate fy. This equals to minus infinity to infinity and fx y dx. So x is between 1 over y and y, no matter which area. So the answer is more easily than the fx. So this is 2y squared ln x. It's from 1 over y to y. The answer is ln y over y squared. So this is the answer of fy. And the picture is like this. It starts from 1 and goes out and down. So this is the graph of fy. This is y, this is fy. And the question 4 is verify fx and fy are valid density functions. So it is easily by doing this. So we know that the fx equals 1 over 2, 1x between 0 and 1, and 1 over 2x squared, 1x is larger than 1. So we calculate this by from minus infinity to infinity fx dx equals from 0 to 1, 1 over 2 dx plus from 1 to infinity 2x squared dx, and this is 1 over 2 plus, so the answer is 1. Now, because this is 1, so fx is a valid density function. And now we know that fy is this ln y over y squared dy, because y is between 1 and infinity, because y is larger than 1. So this is from 1 to infinity ln y to over y squared dy. And this is calculated in the question. Uh, this is the same as this. So we know that it is equals to 1. So fy is also a valid density function. So this is the answer to question 4.